The purpose of this video is to explore several ways of determining a least common multiple. Two terms that students often confuse are the terms multiple and factor. What are the difference between those two things and where do these two things apply? In this video we will look at the difference between those two terms and then also take a long time to look at what it means to be a common multiple or a least common multiple. A multiple is a number that can be divided by another number without remainder. In elementary school, we typically study our multiplication charts. All of those numbers in our single-digit multiplications are the multiples of 1, 2, 3, and so forth. So for example, the multiples of 9 are 9, 18, 27, 36, and so forth. We do have to be careful, like I warned a few minutes ago. There is a difference between the word multiple and factors. We just saw the multiples of 9. The factors of 9 would be 1, 3, and 9. So this is a list of the divisors or numbers that divide evenly into 9. We can know the difference because the factors are a finite number and the multiples go on and on infinitely, so we can never list all multiples of 9. So please remember the difference between these two. We're going to go through what it means to be lists of multiples or common multiples going forward. One thing you may want to watch before we go forward is the process of prime factorization. So please go back and take a look at my video for that if you haven't seen that already. So just to send the message home, let's take a look at a couple lists of multiples of a given number. The first number we'll try is 24. All you have to do is do constant addition to the original number. So the first multiple is the number itself, 24, and then we just simply add 24 or double, triple, quadruple, and so forth. So add 24, you get 48. Another 24, we get 72. Another 24, 96, and so on. A second example will be the multiples of 45. Again, you start with the number itself, 45, and then you just do constant addition or multiply by the next integer. So double that, you get 90. Multiply 45 by 3, you get 135, and so forth. All right. Realize that we cannot list all multiples of a given number because that list would go on forever. Most of the time you'll be asked to complete tasks about common multiples. You'll see when dealing with fractions you need to have a least common denominator. This process of finding that is exactly the same thing as finding the least common multiples. I realize that there are an infinite amount of common multiples between two or more numbers. Most of the time though we want to find the smallest in order to work with the smallest numbers in algebra and arithmetic. So for easy numbers, it's probably just the quickest method to list all of the multiples and then stop once you find the first or the smallest number that they have in common. So for 20, easily 20, 40, 60. You may want to go further and look in the multiples of 24, 24, 48, 72, 96. We haven't found it yet, so you keep going. And then eventually we find out that 120 is the smallest or the least common multiple in both of these lists. So even with relatively easy numbers like 20 and 24, you can say it takes a little time to get through the process of just writing down all of the multiples. So with larger numbers, we're going to use a different method, which is using prime factorization to break things down into prime factors and then working with what they have in common. So for the examples 350 and 245, we'll look at the prime factorization first. Again, if you haven't done this, probably a good idea to go back and look at my video on prime factorization. So we can see the prime factorization of 350 is 2 times 5 squared times 7. And 245 breaks down into 5 multiplied by 7 squared. So you can see the combination of 5s and 7 are going to have an impact, and the 2 will have an impact as well. So the way that we find the least common multiple is kind of the opposite of finding the greatest common factor. In this case, we look for the largest exponent that they have in common for each base. So we look at 2's, and there's only 2 to the first power in the 350, so we will keep that. Then 5, the largest exponent is 5 squared, so we will keep that. And 7, the largest exponent, is 7 squared, so we will keep that. So the least common multiple is going to be 2 multiplied by 5 squared multiplied by 7 squared. Take a few minutes and work that out. Hopefully you don't have to do such large math and mental math, but this isn't too bad if you do. Just be careful and you end up with 2,450. Let's go through a second example to further explore how this works. So the least common multiple between 220 and 684 will be very difficult to write out entire lists, especially with the multiplication process or the adding process. So let's use prime factorization again. The prime factorization of 228 ends up being 2 squared multiplied by 3 multiplied by 19. 684 is a larger number, but we end up with 2 squared times 3 squared times 19. So we look at the prime factorization, we see we have all common prime factors. All we have to do is make sure we again pick the larger exponent of each, and that is going to be our least common multiple. In this case, it's an interesting one because 2 squared multiplied by 3 squared multiplied by 19 is my largest exponent for each prime base, and that actually ends up being 684. So 684 is a multiple of 228 and ends up being the least common multiple between the two in this case. So that's it. You'll typically use this skill when working with simplifying fractions and expressions with fractions, but you'll also see this in a lot of application problems on the SATs and other standardized tests. Thank you so much for watching. For more videos on mathematics, please check out my channel, and if you have any requests, please feel free to send me a comment or a question.